Hello and welcome. Thank you for tuning into my channel. My name is Dr. Bindesh Nunia. I've done my PhD in civil engineering. So today I'll start the lecture series of structure dynamics with MATLAB. In this module, we'll try to solve structure dynamics and vibration related problems using MATLAB. So after this course, you'll be able to simulate structure dynamics problems using MATLAB, and you'll be able to make such codes and run those codes. So before going to this main content, that is the structure dynamics problems and all, like spring mass damper, etc. Before going there, I'd like to tell you that this will be a tutorial course for MATLAB as well. So after, even if you are not associated with structure dynamics problems, or let's say if you just want to learn MATLAB for any other work, this will be helpful for that also. So if you want to learn MATLAB, simply follow whatever I am doing. You don't need to understand. If you are not from civil engineering, or you are not interested in structure dynamics problems, then what you can do, you can simply just mug up the theories and just practice the MATLAB code. So eventually you will learn MATLAB. So if you just want to learn MATLAB, this will also be helpful for you. This will be useful for you. And if you want to learn both MATLAB as well as theory, then don't worry, I'll explain the theory as well as MATLAB code. So if you need any help, then you can contact me through my contact details. And so let us start. So before starting to the main content, what I'll do, I'll give a brief idea about the MATLAB, those who are complete beginner, absolute beginner, and those who are new, those who are aware of MATLAB. They can just bear with me for a few minutes so that I can give a brief introduction. So MATLAB stands for Matrix Laboratory. So here all the operations that we carry out is basically matrix. So matrix multiplication. Now you just have to remember one thing: matrix multiplication rule. So let's say if I have a matrix its size is n by n and n by m, and I have another matrix its size is p by q. Now this one, n represents row, m represents column, p represents row, and q represents column. Okay, sorry, column. Now these are rows, these are called rows, and vertical elements are called columns. Now for a matrix, let's say this matrix is A and this matrix is B. Now A cross B matrix multiplication will only be possible when your M is equal to P. That means this will be true only when M is equal to P. If M is not equal to P, then this multiplication is not possible. Okay, so make sure always you will have to keep this in your mind while working in MATLAB. So if I multiply A cross B, what will be the new size of my matrix? N cross Q. This N and this Q. Now let me give you an example. Let us take an example of a matrix 2, 3, 5, 6. This is a matrix A, and let us take another matrix 1, 2, 3, 2, and this is matrix B. Now size of matrix, how many rows? One row. This is called one row, this is called two row. So two row. First we'll write row and column, then we have one column, two column. So two columns. Similarly, size of matrix is 2 by 2. So A cross B will be, if I multiply these two, 2, 3, 5, 6 and 1, 2, 3, 2. Okay, so always matrix multiplication occurs in row and column. So these row will get multiplied with this column, then again this row will be multiplied to this column. So if I multiply this row, 2 into 1 plus 3 into 3, so this will give me my first element. Next is my, again this row, this column, 2 into 2 plus 3 into 2. Then again second row, 5 into 1 plus 6 into 3. Then again 6 into, sorry, 5 into 2, 5 into 2 into plus 6 into 2. Always row column multiplication. So this is how you got. Now the size of this matrix was 2 by 2. So if you see, these two are same. If I denote it as n m p q, so likewise as I have said here, m equal to p, so these two equal to 2. Now the size of the matrix that we have got is 2 by 2. So this is how it works. Now let us do the same operation in MATLAB. So we'll learn like this few first class, because eventually my goal is to teach you MATLAB, and also structure dynamics will use the structure dynamics to teach you MATLAB. So for both kind of people who want to learn structure dynamics, who want to learn MATLAB, for both of them it will be helpful. Now here itself you can operate, but in the MATLAB, here this is the I would say whatever operation you will be doing, it will be visible over here if you do not put semicolon, and this is called command window. Now I'll open the editor, edit. It's simply write edit and press enter, so it will open editor. So this is the path where files are saving. Now you need to always keep a habit to change the path. So I'll go to desktop, I'll create a new folder, I'll name it as MATLAB structure dynamics tut. Okay, so my folder has been created. I'll select this, I'll click select folder. So now see, my path has been changed. Now everything will be available in this folder. Now first of all I'll have to save the MATLAB code. Let's say I'll name it as tut1. Sorry, you cannot give space etc. You can write tut1. You cannot give space and save it. So tut1 has been saved. Now you can write your code over here and you can execute, and those will be visible over here. Now this one is the script or whatever data you have in your folder, that is this folder, the folder that I have created, where it is, somewhere here I have created, yeah. So whatever data I have, this will be visible over here in this current folder. Let's say if you are not getting this type of visualization, simply right click on these things, right click on the top, and you'll get all the options. Okay, let's say I want to close or I want to visualize. This is called dock and undock. Undock means it will be like this. See, I don't have that window over here, it is separated, and I have undocked now. Now I'll dock it. That means everything will be visible. So it becomes easier. Like you can see whatever file you have in your folder and all the variables that you will be using over here. Variables means here, if you see, I have assigned matrix A something, matrix B something. So all those things will be visible. What is A, what value you have assigned to for A, what value you have assigned for B. So everything will be visible over here. And this is called editor. So here this button is used for running the code. Whatever code you will be running over, writing over here, you can run that code using this, or you can select it and right click it to execute the command. I'll show those things, don't worry. And sometimes there are one more thing I just want to show you. Yes, these things, sometimes these things are not configured as it is shown in my PC. So you can go to layout and you can switch on, switch off. See, if I switch off workspace, it is deleted. If I switch off current folder, it will be deleted. You may have configuration like this, so you can switch on all those from here, and you can drag or drop anywhere. Let's say if you want your variables to be here, you can work like this. Okay, so it doesn't matter, you can just drag and shift. Now let us start. So I have assigned matrix A. I'll write A equal to, so always write the matrix in third bracket. What is the matrix I have written over here? It is 2 3 5 6. So 2 space 3, and now I need to go to the second column. Second row. First row I have written, now I will go to second row. So to go to second row, what I will do, I'll simply use a semicolon. Okay, if I use semicolon, what is second row? 5 6. So 5 space 6. Now this will give me a 2 by 2 matrix. If I execute it, see, it is visible over here. And as I have said, A, I have assigned this variable, it is visible over here. Now if you double click this, it will be visible in terms of matrix over here. Okay, now see, I have executed it and it is visible over here. Now let's say you have n number of, like you are writing code, like you have 5000 or 6000 coding line. If you are not putting a semicolon at the end, everything will be displayed over here. And displaying a small matrix is not a big problem, but let's say if you have a big code, displaying everything takes lots of memory. So we use a semicolon to suppress the response. See, I have executed right now, it is showing me just execution, but it is not showing me this value. Okay, I'll clear the screen. To clear this screen, you just have to write CLC. So if I just use CLC, it will clear my screen. Now see, I'm evaluating, or I can run it. I'm running this, but nothing is visible over here, but it is getting executed. But if I remove this column, semicolon, if I run it, it will be visible. Okay, so always keep a habit of putting semicolon. Now you can write matrix B in the next line, or you can continue in this line giving a semicolon itself. Similarly, give third bracket, close the line. Now what is the B matrix we have written? 1 2 3 2. So 1 space 2 semicolon 3 space 2. That's the matrix we have written, I guess. Yes. So now if I execute this, you will see B will be available here, but it will not be visible over here because I have put a semicolon over here. So see, it is just the execution it is showing. If I run it, nothing will be shown over here. So A, B both are here. Now I can operate. You can just press enter and keep it in second line, no problem. And I can operate. Now I want to get a C matrix. C will be A star B. Now if I execute, I am getting A star B is 11, 10, 23, 22. Now how 11? See, this is 9 plus 2, 11. So likewise we have got a matrix. And next, let's say if you want what is called okay, now as I have said, I'll delete this example and let us take another example. Here now let's say a matrix A equal to 2, 3, 5, 6 and a matrix B equal to size of this matrix is 2 by 2 and 1, 3. This is another matrix. Okay, so size of this matrix is row, 1 row and 2 column. So can you tell me whether multiplication is possible or not? If you again go with the same rule, n into m, p cross q. So again I am telling those who know all these things about MATLAB, they can skip this lecture, because I just want to start from the beginning for all those who are absolute beginners in MATLAB. So I just want to give them a basic idea about this operation. So now here m is not equal to p, so A cross B is not possible. Okay, this is not possible. Now if I what I can do, A cross B is not, but A into B transpose is possible. Now how? B transpose will be, row will become column, 1, 3, isn't it? It will become 2 by 1. Now B transpose has a size 2 by 1 and A has a size of 2 by 2. So now the size of what will be the size of A into B transpose? It will be, these two are same, these two are same, so this will get cancelled out. Size of this will be 2 into 1. Now let us check. A is 2, 5, 3, 6. Again I'll edit it, 2, 5, 3, 6, and B I have written 1, 3. B is my 1, 3. Now if you see, if I try to execute this, I'll try to run this, it will give me an error. See, incorrect dimension for matrix multiplication, check that numbers column in first matrix matches the numbers of rows in the second matrix. So this will give you the error code that the size of matrix A and B is not correct for multiplication. Now if I make B transpose, now how to make B transpose? Simply put a what is called apostrophe that we usually use, this sign. I do not remember what is the name of usually we use for apostrophe, as let's say you want to write somebody's name like John's father. So how you write? John apostrophe as John's father, isn't it? So that sign you just have to use over here. Now if you see, this multiplication is possible, so it becomes C. Now C has become a matrix which has having 1 column and 2 row. So that's how, 1 column, 2 row and 1 column. So this is a basic idea. Remaining you just need these many this is sufficient for your basic idea, and don't worry about that. We'll proceed when we start learning other things. You will be able to learn MATLAB automatically, so you should not be worried about it. Okay, now one more thing, if you need some things inverse, okay, matrix inverse. So let's say I need A inverse. So let's say C will be A inverse. Okay, so you just have to find out A inverse manually. If you want to find out A inverse manually, that is also okay. But if you just simply write A inverse, that will give you the inverse value of A. Okay, so what I'll do, I'll simply write INV, give a bracket and enter. Make sure these are case sensitive. See, I have written capital letter A. If I write a small letter A, it will not take the value. Software will give you a simple error. See, it is undefined function or variable. That is, it doesn't know A, but it knows capital A. If I write capital A, you see, it will give you. So this is how you can calculate inverse of A. Okay, or let's say if you want to find out what happens, let us check what happens with this. It is giving the same value. Okay, now what is this? This is power a to the power -1. That's how we write, right? A inverse, A inverse. So in this is 1, this is 1, A inverse. Now this is how we write in manually, and in MATLAB what we write, A. Whenever you want to give power to any letter, any variable, simply use this sign and write -1 is the power. Let's say A square. How you will write in MATLAB? You will write A power 2. So it will take the power. That's all. So these are basic things. I don't think you need anything else apart from this. This will be sufficient for your beginner to proceed. Remaining thing we'll learn when we proceed with the uh, with our problems, etc. So we'll be able to easily proceed. One more thing, I just want to give you an idea. Let us do a simple, what is called simple test of okay, sorry, I should not have deleted all this. I should not have deleted all this. I must keep this. Sorry. I just want to keep this as record, so that if I give you this code, if you need this code, then I can give it and it will be helpful for you to learn. I'll keep a record of all this. So if I keep a record, it becomes easier. So I'm keeping a record of all this. Now one thing also I have forgotten to mention, that CLC will clear this screen. If I execute CLC, if I simply select this and execute, it will clear the screen, but these variables are not getting cleared. If you want to delete all variables, you can simply write clear all. So if I simply select this, it will clear all the variables. So always I use these things. Let's say you want to assign a new variable all the time, so I utilize these two things. And one more thing, okay, now let us try to do to find the sum of first and natural numbers. To find the sum of first 10 NATURL natural. Now this is a comment, okay, so you cannot execute it. Okay, so what you can do, to write a comment, you just have to add percentage sign. So these are comments, so this will not be considered as coding code, and it will just be used as a comment. Now let's say we need the sum of first 10 natural numbers. So first number n equal to 0, let us write, okay, uh, what we can do is I'll write for I is a variable, I equal to 1 to 10, and I'll end. So see, I have written a for loop and I have ended it. Now for I equal to 1 to 10, okay, that means I will vary 1 2 3 4. So for first time the code will run and it will take the value I equal to 1. Again, this is a loop, okay. So loop means what? Whenever I am writing for, whenever I am using for, that what happens, for I is a variable, you can write your name. Let's say my name is Bindesh. So Bindesh equal to 1 to 10. This colon is used to represent 1 to 10 means, and I am ending the loop. So this is one loop. So what will happen? Software will come over here and it will see that okay, for loop is there. That means first it will take 1. So first execution it will take Bindesh equal to 1. If I write Bindesh over here, then it will display me that one. So instead of I, if I write my name Bindesh, so, and I want my software to display what is the first loop. So I can use pause button over here. So if you simply click over here, it will give you a pause button. Now if you try to run, see my command has started from here. It has checked first line, second line, third line, fourth line. These are empty, so it has checked, it has got nothing. Now my command is here. If you see the error line, and my command is here, it is taking Bindesh. It has found that it has to go from 1 to 10. So first it will take, now you will just go increase one step. So next line is 8. Why? Because my 7th line is there is no 7 line. So what I'll do, I'll not keep any empty line. I'll delete all empty line. Doesn't matter, even if you keep, no problem. I have simply added a pause over here. I have run the code. It is standing over here. Now here it has taken Bindesh equal to 1. Now what it will display? 1. See, Bindesh equal to 1. Again, now it is at the end of the code. Again it will go for here. Again it will take the, because it know that for loop it has to run until it has reached 10. Now what will it will take? Bindesh equal to, just check, 2. Why? Because for when I write for 1 to 10, that means it is written 1 comma 2 comma 3 comma 4 comma dot 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 10. So every time it will run this loop, it will take, first it will take 1, then it will take 2, then it will take 3, then it will take 4. So whatever variable here previously I have given 1, you can write your name or A or B, any variable. So these will be getting one by one values will be assigned. See here it is changing, okay. So this operation is simply used many ways to execute the solution. Now we need to find the sum of first 10 natural numbers, okay. So I'll again make it I. Now sum of first 10 natural numbers, that means 1 plus 2 plus 3 plus 5, 4 plus 5, isn't it? So what I'll do is you can simply execute it. I equal to I plus 1, okay, and this will give you So what happens? Let's say, let us check what is happening with I plus 1. Again I have quit the program. I'll run over here. It has now this I value is, if you simply place your cursor, you can see what is I is 1. So 1 plus 1, new I will be 2. Now this is at the end of the code. So here this I has become 2 and this was already 1. So this one initially it was 1, so 1 plus 1 it has become 2. Now again it will go over here. Now here if you see, again I equal to 2 and we have already assigned I equal to 2. Now what will happen? I is my 3. So it has already performed. So if you see what happens, 1 plus 2 plus 3 plus 4 plus 5 plus dot 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 10, isn't it? So 1 plus 2 is my 3. Okay, in next execution, here if I simply continue, it has become 4. Again it has become 5. So I is simply increasing one by one, 1 2 3 4 5. Likewise, that means here at the end, here I has become 5. Again if I come at the go for the next loop, now my I is 5 and this will become 6. So this is simply increasing. Now to make the sum, I'll write sum equal to sum plus I. Now what is happening here? Sum, this will give me my total value. Every time it comes, like first will be summing 1 with 2, then 2 with 3, then 3 continuously. Whatever I value, we just have to keep adding. So initially I will define my sum equal to 0. Initially my sum was 0. Now if you see, if I suppress this and again I try to run it, so my sum is 1. Why? Because sum was initially I have defined 0. When it come to the loop, it taken sum equal to 0 and I equal to 1. 0 plus 1 equal to 1. Next it will be, here sum was 1, I was 2, 2 plus 1 equal to 3. Now it will be 6. Why? Because this 2 plus 1 equal to 3, then 3 plus 3 equal to 4, then 4 will be added up. So likewise, if I simply continue, it has given me the complete sum. So now at the end you should display what is sum. So suppress this and remove the pause button and display what is the sum. So it has displayed you the total sum. Now I am just simply giving, even if you don't use this one I have just give. Sometimes it is required to run, it is required sometimes. Okay, let's say if you want some step to be not one by one, but it will take let's say if I suppress this and if I resume it, I'll show you what happens, why this logic is required. Now see, here here I is 1, but here this I will become, or let's say yes, this I will become 3. Why? Initially it was 1, next it has become 3. So sometimes we need to run it 10 times, but we want to take like 1 3 5 7 like that. So if I again run it, now the I is 2, but here it will take 4. So when you don't need 1 2 3 4 5 6 continuously, you need 1 3 5 like that. In that case you can utilize this logic. Okay, so for the time being I'll keep it like this, and again I'll keep a record of this. Okay. Next, so I guess this much is sufficient. I can directly go to the go to my first problem of structure dynamics. Okay, okay, we'll see the plotting etc. when we do the problem. Okay, we'll not go to the problem each and every small tutorial, because our basic aim is to teach you the structure dynamics. And what I'll do is, when you perform such structure dynamics and when you will be plotting the response, there you will learn how to plot. So to learn the MATLAB, you should not just start practicing anything randomly. To learn the MATLAB better, you take any problem and try to solve it. So eventually you will learn the complete MATLAB. Okay, now let us take the problem of spring mass damper system. So we'll have this spring, and then just forgive my drawing. Why it's not coming in? So again, and this will be my, again let us give some space, and okay, and this is my spring, and next is, this is my ground, it is connected to a ground. Okay, this is my ground. This is the final equation of motion we'll be getting for this. Now what is u dot? U dot is the initial displacement, u dot 0 is the initial displacement, and u dot u of 0 is initial displacement, u dot 0 is initial velocity, omega n is damping, sorry, omega n is the frequency. And if I write everything clearly, then what we had a equation, system of equation, m u of t double dot plus k u of t equal to 0. There is no external force, and we have got the solution of this, where omega n is my square root k by m. Okay, so these two things we have got. So I'm not going deep into the solution and etc., because that will unnecessarily lengthen the video. So what I think is, from next time onwards, I'll take two separate classes, where in one hand I'll explain the structure dynamics, and on other hand I'll solve those problems in MATLAB, because these combined will create a problem. Because see, those who are only here for learning MATLAB, they'll not be benefited for all this solution analysis. So I'll solve this equation in this first class, and from next class I'll separate the structure dynamics, and the same problem will solve in MATLAB in a separate class. So that will be helpful. Now we'll try to make this code in MATLAB. So let us first write, quit everything. I'll write u of t equal to, okay, I'll everything I'll use capital letters. U of t equal to u of 0 star cos cos, give bracket, cos omega n, sorry, cos omega n t, cos omega n star t, then plus, sorry, plus, give a bracket here, u dot, u dot 0, u dot 0 upon omega n. Make sure when I'm writing everything is there, you should not match capital letter and small letter, omega n, and then star sine omega n and star t. Star means multiplication. Now we have written the total equation. What I'll do before that, see, if I try to execute now, software will tell me that there is no such variables, isn't it? We have not assigned u dot 0, cos, cos we know, software knows omega n t, so we'll try to assign one by one. So u of 0, let us take a problem where initial velocity was 2, okay, 2 meter per second, okay. I'll write a comment, initial displacement to 2 meter and u dot 0. I'll simply copy this. U dot 0 is let's say 0.1. So what it will be? Initial velocity. It will be 0.1 meter per second. And these two are required, and we just have to define, find out omega n, Wn equal to, we know, sqrt square root k by m. Now k is the system stiffness, you have to define, and just mass of the stiffness. So system stiffness, let's say 156. So I'm taking random value, and stiffness force required to cause unit displacement. So let's say this is in Newton per meter. This is in Newton per meter. Okay, I'll use comment option and I'll suppress this, and mass, let's say 10 kg. Always keep SI units, 10 kg mass, and this is stiffness. Okay, so now all the values are defined. If I try to solve, we'll get, but the thing is that here one thing is missing, t. Now t, for how much time you want to see. So these problem we want to see it for 10 seconds. Let's say this you have been given this setup where is a mass is attached to a spring, and what you do, you have simply pulled this mass upward and left it. Simply you have given little bit of displacement and you leave it. So what will happen? It will vibrate like this. It will go up. Once you have pulled up, it will go up. Then again it will come down, go up, come down, like this. So you have been asked to monitor the response for 10 seconds. So t equal to 10 seconds. So how the response will be monitored? Let's say t equal to 10 seconds. Now to track the history at t equal to exact 10 second, where it will be, you can simply find out. like after 10 seconds where it will be or what will be the response, you can find out. But you have been asked to monitor the response each 1 second. In 1 second, how the what is the response? That means we'll divide 10 second in 1 second, 0 1 2 3 4 7. So likewise we'll plot the history. So again we'll use for loop for t equal to 0 to 10 and give an end loop, and here in bracket simply give t. So it will note down the response. Now run the, so there is a problem. Indices must be positive integers or logical values. So okay, this one will be 1 to t, sorry. Okay, we'll track from 0 to 10. Again, here one thing that will come into play. Here I have used this condition. This one I have explained you earlier. Okay, so this condition will play. If I write I equal to 0, and here I'll write I. Now why, if I try to execute, it will give me the same error. Why? Because see here, if I pause the program, here I is 0. That means this is a vector. So you cannot write a vector like vector has to be some dimension, right? If A is a vector, then it has some dimension like 1 2 some values. It cannot be 0. If it is 0, means value can be 0, no problem. But here A of 0 means there is nothing in the system, so it cannot be A of 0. It has to be A of 1. Then only, that means there is only one element in the model. If A of 2, that means it will have 2 element in the vector. So that's why it is giving me that error. One more thing, whenever you are facing in MATLAB, whenever facing your such error, simply copy this error and paste in Google. You'll get all the problems that you have. Now if I show you, here I equal to 0, but I need I equal to 1. So what I'll do, I'll write I equal to I plus 1. This is a very strong logic which we can use in many a times. Now you see, again if I run it, you will not see I equal to 0, it will become 1. So each leap it will keep on increasing. So if I simply run it, we have got a history of u of t. Okay, now let us try to plot u of t. plot plot u of t. Now if I simply again try to run it, it will give me the plot of u of t. So this is how, you see, we should have got the response of in the form of sinusoidal curve like this. Okay, but here we are not getting. Why? The reason lies over here. See, as I have said, omega n is the frequency. Again, let us go to the definition of frequency. It says 12 cycles in 1 second. Sorry, 12 radian per second. Omega n is nothing but my radian per second. It is radian per second. This is my what is called angular frequency. Okay, this is my angular frequency. So this is radian per second. Now in 1 second it is going 12 radian, isn't it? 12 radian in 1 second, it is going 12 radian. Now if I want to get my what is called cycle per second, okay, I have to convert in cycle per second to know that how many second is required to get one cycle. See here, it has not performed one cycle, it has simply going down. Now if I increase the time period to 100, if I increase the time period to 100, you'll see a different scenario. It is increasing, and here I have made it 100, but here I have not increased it. Sorry, it will not be 100. Okay, I'm checking it for 100 seconds. So see, in 100 seconds it has not completed one complete cycle, it has just completed, I would say, 90 degree. Or I would say, if I have to give the example for this, what it has done is, try to understand what is happening over here. I have given an initial displacement, it has gone up, and it has simply gone up, and it did not come back, it is yet to come back. So this represents only it has gone up. Okay, now if I increase it to 1000 time period, I am checking it for 1000 seconds, you will see that yes, now see, it is going up and down, up and down, up and down. So what happens now? I need to find out the time period, like in 1 second how many cycles it can perform. What is the time period? Okay, so we know that, so the frequency in cycles per second, we want in cycles, because this one you have got, this is cycle, this is, if you see, starting from this, here one cycle is getting completed. If I keep my velocity 0, then I'll get better visualization. Okay, let us keep the velocity 0, let us check. Okay, and initial displacement is also 0. There will not be any response. Let us keep some value, no problem. Okay, now see, I have to find out the frequency, that is in cycles per second. So I'll write Fn in cycles per second. It will be 2 pi upon omega n. So this will give me the frequency in cycles per second. So what is the frequency in cycles per second? Fn, the value of Fn equal to 0.5. That means 0.5 cycles in 1 second. So this is very less. Now to make you understand, what I'll do, I'll trick some data. Okay, so little mistake I have done, that Fn, it is not 2 pi upon omega, it is omega n upon 2 pi. So from there, if you see this, the here the Fn value, that is the cyclic frequency is 1.99 cycles per second, nearly 2 cycles in 1 second. Okay, nearly 2 cycles, it shows Fn equal to 1.99, 2 cycles in 1 second. If you see time period required for 1 cycle is 0.5 second. So if you see, for 1 cycle it is 0.5 second, and in 1 second it is simulating 2 cycles. So if I simulate it for 1 second, so 2 cycles in 1 second. Now if I run this code, you see 2 cycles. What is the definition of frequency? I have told you that you have started from your home, from this point. If I expand this, you have started your home from your home. Let's say this is your home, you have started, and this is your college. Okay, now this is your college, sorry, this portion is your college, this portion is your college, and this is your home. So you have started from your home, you have come to your college, then again you have come to your home. So one cycle. Again you have started from your home, you have gone to your college, you have reached to your home again. So this is 2 cycles. Now how much time it is required to perform 2 cycles? See, 1 second. And frequency, again you see 2 cycles in 1 second, 2 cycles in 1 second. That means how much time it will be required to perform 1 cycle? It will be 0.5 second. If you see, if I run this, you will see that 0.5 second was required to perform 1 cycle. So this was a basic coding session, I mean MATLAB. So this will be helpful for you initially, because here you learn lots of things. You just practice this code. If you have any doubt, any query, I'll not go deeper in this code anymore. From next class onwards, I'll keep 2 separate session. One is for dynamic analysis, one is for MATLAB code. Now, one thing you can here simply the graph that you have plotted, you can rename, you can name the axis of the graph. You can simply name the axis of the graph like x level, y level, or you can change the color of this graph. So if I give a comma and give a quotation, single quotation, and let's say I write y, so what it will happen is it will give me the graph in yellow color. If I make it, sorry, if I make it red, it will give me in red color. And if I make it red dot, then it will give me dotted line. Dotted line, see, dotted dots are 3 dots are there. So if this is a long curve, you will be able to visible more things. If I give a dash, then dash dash will be there, dash dash will be there, sorry, dash dot, dash dot, see, dash dot, dash dot. So these things you can vary. I'll show more things about this, like how to give x level, y level. You can add those things also. So you have seen this. Now if I have to add a title of the graph, so what I'll do, I'll simply write title and the name of the graph. So you see, title, simply write title, and the name I'm writing is graph, or I can write free vibration graph. You have to write in comma and quotation. If I run this, see, name has come, free vibration. Now I have to name the x level and y level. This is x and y axis, so I'll simply write x level. X level is my time, so x level has come as time, see, bottom. And again, if I need y level is my amplitude. So likewise, this is the graph plot, and you can use legends also. So we'll see in next consequences classes, next subsequent classes, how to give many more things. So this is how we can write. So this is the free vibration problem. Now let us talk about deal about the graph little bit. Talk about the graph little bit to understand this graph in a structured dynamic way. So what I'll do, I'll take little fine step. So I'll get a smooth curve. Okay. Now if you see, what is the difference between these graph, and I'll copy the same thing. I'll copy the same thing again, and or I'll again add a for loop. Better, let us, actually what I want to do, and to compare two different velocities. Okay, so what I'll do, I'll again add a for loop. For I'll again add a for loop. For for just give a random value 1 2 2. Just I want to compare two different values. Give a end, and this plot, let's say velocity, name it. I give two velocities, make a matrix of two velocities. Let's say one is 0.1 and one is 0.8. Okay, now this is a matrix that I have created. Now if I simply, instead of directly taking the velocity, if I tell the software take velocity equal to yy, so what will happen? First yy value will be 1 when the loop will run, then velocity, it will be 1 over here, so it will take this value, and in second loop this yy will be 2, so velocity it will consider this. So for that I'll simply use the hold on option. Hold on, and I just try to plot what is happening. So see, we see there is two graph, and what I'll do one more thing. I'll not mark any color over here, so it will give me two different distinct color. Sorry, I have to remove this. Okay, it is giving me two different graph. So what I'll do, I'll change the velocity a little bit higher so you can see the difference. Okay, now see what is happening. This one, the blue color, you see, this one is for velocity 0.1, and this what you call yellow color or brown color, whatever, it has velocity 8. So when the velocity is increasing, the initial slope from where it is start, it is changing. So the velocity, when the velocity was 8, the curve, how the curve has started, if you see, if you try to understand how the curve has started, the curve has started something like this, isn't it? And when the velocity was less, 0.1, it is starting like this. Now you will see when the velocity is 0, what will happen? Let us make the velocity 0. Let us make the first velocity 0. Now if I show you the velocity matrix, this is how the velocity matrix looks like: 0.1 and 0. So 2 column, 1 row. Now here the velocity is, I am assigned as a variable. So when this is 1, that is yy will be 1, that means velocity will be considered 0, and when y will be 2, the velocity will be considered 8. So if I run it again, you will see two different behavior of the graph. See, if I show you this, see, this portion, if you see, one is going up, that is the velocity was 8 for brown color or what you call, and for green color, if you see, or blue color, I have this color blindness, it is coming directly down. So what is happening, when the velocity is 0, it is coming directly like this. Sorry, it is coming directly like this. Okay, when the velocity is not 0, it is going like this. Now let us do the reverse thing. Now what we will do, will keep initial displacement 0. Now change this matrix to displacement I'll write displace, and initially I'll keep the displacement 0, then I'll keep a displacement of 2, which is over here. Velocity, let us keep the velocity as 8. I have now made the velocity constant, and to vary the displacement, what I'll do, I'll write displacement, and in bracket I'll give yy. So what is happening over here? Just pay attention. What is happening? Initially it will take 0, then the velocity displacement will be 2, but velocity is constant. So what will happen? Let us plot this. So now when the displacement is 0, see, it is starting from this point, directly from 0. Amplitude is 0, and when the displacement is 2, it is starting from this point. But if you see, both the curve is having same slope at the point, because velocity is constant. Here velocity is constant, but displacement is changing. Okay, so that's all about, that's what I just wanted to explain you. And if I run it for 1 second, you'll see there is 2 cycles. 2 cycles will be clearly visible. See, 2 cycles. If I keep 0 only, and I want to run only 1 second, for 1 second, see, what is the time period? 0.2, yeah, 0.5. So see how much time is required to complete 1 cycle. 1 cycle is getting completed in near about 0.5 second, which is here visible, 0.5 second, and second cycle is also getting completed over here. So there are 2 cycles. So this is how system is vibrating. And if you want to take the velocity and acceleration, so you'll have to take the derivative of this one time, u dot I, and if you want to take the acceleration, you can take derivative twice, that u dot ti, u dot ti and u double dot ti. So you'll get the velocity and acceleration. So that's all. Thank you for watching this video, and please don't forget to subscribe my channel and share this video.